that for Amazon. And this means that if you're running databases and applications that you've created and licensed and paid for inside the public cloud, in other words, you don't know where it is because it's in Amazon somewhere in the internet, you can actually still do full enterprise level backups. You can actually have backups and recovery and all the sorts of facilities you'd expect, and these are actually backed up inside Amazon's data centers to the S3 facilities in the same way that you might do in a private cloud, but it's using specific technologies that we've worked with Amazon to provide. We actually have a series of software as a service applications available today as well, ranging from ECRM through our collaboration suites right down to specific application suites such as our drug safety components. And these are all licensed and engineered to operate as a software as a service environment in a cloud, and these can be actually run by ourselves or by third parties to provide these, and we have the licensing and the engineering models. And internally inside our all our products, where relevant, are being engineered to provide federated services, shared services, and all the requirements to allow it to run as software as a service or run in the cloud as a platform as a service. So future versions of our products will become more and more friendly towards the cloud. An example of a third party. So as I said before a little while ago, I mentioned that we have a suite of products, a cloud operating and management platform that we use to manage our own facilities, which I'm going to come to in a moment, our own public cloud and private cloud facilities. But we actually will sell those to our customers as well. So they are they're off-the-shelf, if you like, products that we sell to customers. And an example of a customer taking advantage of this is Rackspace, and Rackspace have used our cloud infrastructure platform and our databases and our other products, and are actually providing platform as a service to their end customers on our infrastructure, but in their own environment. So so that's private cloud, public cloud, private cloud, and I also wanted to show you the quick one, which is Oracle Application Express. Now, Apex, as it's colloquially known, is a public cloud, a fully public cloud, platform as a service provided to anyone who wants to use it by Oracle. And this is a real next-gen generation cloud product. It's a true cloud product. In other words, you can go onto the website, you can create an account, you can actually use all the software facilities that are available there to create your own application in its entirety. And then you can export that application from Apex to your own data center to actually put into a private cloud. You can export it into an Amazon EC2 public cloud or another third-party cloud, such as an Apex host. As you can see, there's a whole host of third cloud providers or private cloud providers that will host the applications that you create using this self-service application development environment. So I just wanted to highlight our public cloud offering. So Amazon EC2 is a very well-known, recognized cloud platform. It potentially could be considered the granddaddy of the cloud name and cloud concept as it is today. But in actual fact, Oracle has been providing software as a service, the managed services, to the public through its on-demand service for many, many years already. And this is effectively utilizing our own products to provide a very highly efficient data center, which we provide to our end users. Over 3.6 million end users are running their services on our on-demand platform, and these are just some of the stats that we're running out. One of the key things is that through the cloud technology, we were able to reduce the amount of hardware by 67%, and increase the utilization of the CPUs from 9 to 55%. So much greater utilization of the equipment at a much better cost per CPU cycle. And then we have a private cloud as well. This is internally, I'm going to give you an example of 2 private clouds that we run internally. One of them is actually a private cloud, but external facing, and it's our Oracle University. We have thousands of students a week are coming into our Oracle University for training, and we provision and we provide obviously training systems for them to use. We do this virtually. So this is on demand, 2,300 environments automatically provisioned every week, using 1/10 of the hardware that we used to have to use in order to provide this education facility. We've massively increased the utilization and therefore so the CPU per dollar is much more optimized. We've reduced the floor space, power consumption, and we've actually been able to increase the utilization of the equipment so that we're providing more function, as in education, for the dollar, rather than spending that money on hardware resources or other resources. And then this is quite special as well. Our internal development environment is actually a self-service private cloud. We have over 20,000 developers. When they want to do perform a build, when they want to compile some code on one of our products, rather than sitting there on their desktop or their laptop and running the commands there, they actually submit the job into our self-service Oracle IT development private cloud. They submit the job is put into the cloud somewhere, the job is processed, run, and then completed, and the user is notified that the job has been completed. He can go and retrieve his work and test it. And this has massively increased the utilization and optimization of our hardware environments. It means we don't have idle systems, and it also means that people who are performing very large jobs aren't limited by the hardware in their specific environment. They can actually use the whole of the hardware for those environments, which means we're optimizing the job functions of those developers themselves. They're not sitting around waiting for compilations to be completed. They're able to do Oracle development work on a much more proactive and continual basis. So that is the end of my presentation, and I hope as a result of this you have an understanding of the different types of virtualization and why virtualization is important to the cloud, why it is the cornerstone, the fundamental level of the cloud, what different types of cloud are, and how Oracle is involved in the cloud even today. So I'm going to open the floor up to questions.
Well, thank you very much for that, Wayne. Very, very thorough and informative presentation. Right, we do have a couple of questions that have come through on the questions and answers area. The first one is from Tony Kay of Capita, and his question is, how has Oracle license pricing changed with regard to dynamic cloud computing, specifically based on CPU usage? So, for example, if I have several LPARs, but only one of them is in use at any one time, would I only be paying for the one LPAR or for all of them?
Okay, I can answer that. So I'm not. Oh, sorry. We do recognise hard partitioning. So with physical partitioning,